The deliverables of the Catchment Care project include a water body actions in Catchment's task to investigate and implement the control of chemical escape from land use. This work focused on the Finn catchment and is undertaken by Lochs Agency and Donegal County Council. There are several land use activities which have the propensity to cause export of chemicals from land into watercourses, where they can persist and be transported to locations far away from the original land use activity. Chemical introduction to the aquatic environment can occur in both surface and groundwater systems. Introduction of herbicides and pesticides to the aquatic environment can have damaging effects on non-target species. These chemicals are designed to target terrestrial pest invertebrates, but if introduced to the watercourses, they will indiscriminately affect aquatic invertebrates also. The chemicals can cause direct macroinvertebrate and fish mortality, as well as having indirect impacts by causing functional and behavioural changes in some species. These changes may affect the delicate balance of the ecosystem and have the potential to cause complete ecosystem collapse. In the Finn catchment, the Water Framework Directive status of many water bodies is failing, and this metric is partially influenced by Q-score assessments on macroinvertebrates. Declining macroinvertebrate populations were historically perceived to be influenced by chemical export from two main land use practices, sheep dipping and forestry. Agriculture and forestry make up the majority of the land use in the catchment. The River Basin Management Plan also highlights these two sectors as some of the largest contributors to failing water quality in the Northern Western River Basin District. The first step in this investigation was to look at the chemicals used in these practices in order to get a handle on which chemicals were most commonly used, what their target species are, the functional effects of the chemicals, persistence and known impacts on the environment. This study formed the basis of a literature review from which we ascertained that the most prevalent chemicals of interest to our study are acetamiprid, cypermethrin, a group of chemicals called organophosphates with diazinon in particular. The herbicide MCPA was also identified as of concern and in need of some investigation. Acetamiprid is an insecticide and part of the neonicotinoid substance group. It's ideally used to control hemiptera, so true bugs, in particular aphids. Acetamiprid is extremely soluble in water and can be volatile. It does not show great penetration when absorbing into soils, although it may pose a risk of transference to surface and groundwater. This chemical works by causing hyperactivity within the neurons, muscle spasms, and eventually death in insects. Acetamiprid is used for defense against pine weevil damage to conifer seedlings. Acetamiprid is mobile and it's not likely to persist in surface soils. However, it can move to surface water through spray drift and through runoff if it rains soon after application. The main pathways by which it is broken down are soil microbial action and photodegradation when exposed to UV light. Cypermethrin is a pyrethroid insecticide. It's common growth and spread of large pine weevil in certified forest plantations in Ireland. Quailshire are replacing this chemical with acetamiprid though. Cypermethrin is also an active ingredient in a number of sheep dips. Essentially, this chemical results in the effective paralysis of target insects, which inhibits their ability to feed, and so the insects eventually die of starvation. Previous applications in forestry were generally made in two stages. The first application involved dipping of bundles of plants in the cypermethrin insecticide solution before planting, and the second application occurred via spraying after planting. Cypermethrin is an active ingredient in certain sheep dips, and it protects the livestock against sheep scab, blowfly, headfly, ticks, lice, and keds. Cypermethrin is very highly toxic to water insects and highly toxic to fish. Runoff of cypermethrin-bound sediment to watercourses could cause potential flush, which could kill macroinvertebrate populations. Cypermethrin also readily binds to soil, and the main pathways for breakdown of the compound are by soil microbial action and photodegradation. Organophosphates are commonly used in pesticides and have been for over 40 years. Organophosphates have the potential to bioaccumulate in aquatic fauna and have the capacity to persist in the environment for years under the right conditions. There are three different elements to the vulnerability of fauna. They are susceptibility to exposure, direct sensitivity, and recovery capability. Increased concentrations of organophosphates in aquatic systems are often correlated with several other stressors, such as nutrients, particle transport, habitat degradation. The loss of functional performance in invertebrates caused by organophosphates may have cascading effects, reducing the amount of energy for growth and reproduction, and also the chances of the organism successfully reproducing, competing for food and space. Organophosphates have been found to directly impact fish species as well. It's been found that organophosphates decrease growth rates, decrease reproductive behavior, and they also directly cause neurological disorders and deformities within the spinal structure, gills, tissue, kidney, and liver. Prolonged exposure to organophosphates in the aquatic environment can also cause changes in fish behavior, such as restlessness, agitation, loss of equilibrium, and coordination. These behavioral changes have the potential to cause suffocation and mortality. In order to get a clearer idea of the prevalence of use of these chemicals in the fin catchment, the team carried out surveys to investigate the potential sources. The team undertook a fixed sheep dip survey. Prior to the survey, we knew of sort of 43 fixed sheep dipping locations, and these were known and documented in the catchment. The team started by gathering information on local sheep dipping practices by attending sheep marts in the fin and asking farmers to complete questionnaires. The results of the questionnaires have helped the team to better understand how farmers use, handle, and dispose of sheep dip. The team then conducted a significant survey using Survey 123 of all sheep dip locations in the fin catchment and compiled the sheep dip dashboard. This is an interactive map that shows the location of all known sheep dips in the catchment, and it includes additional information and photographs. Based on the newly collected data, the survey team has now compiled a survey dashboard of 103 both public and privately owned sheep dipping locations. It is hoped that, coupled with the information from the questionnaires, this information will help to build a better picture of when and where chemical exports from sheep dipping is likely to be an issue in the fin catchment. This information will help with targeted responses in the future, as the dashboard highlights clusters of actively used sheep dips which could have an impact on water quality. A desk study was carried out to identify and map known forestry plantations in the fin catchment and ascertain whether they are publicly or privately owned. Results find that within the fin catchment, forestry covers around 108 square kilometres, which is about 20% of the whole fin catchment. The total forest area is made up of 482 privately owned forests, equating to just over 28 square kilometres, and 115 quailshire forests, equating to just over 80 square kilometres. Ground surveys were conducted on the publicly owned plantations that were adjacent to significant water bodies. These studies recorded information on the age of the forest, if any clear felling had taken place, the existence of drainage gullies, if any, the pathways of connectivity of the drainage to the local watercourse, the existence of buffer zones, if any, and in situ water chemistry analysis of pH, conductivity, dissolved oxygen, and temperature. The survey was carried out using the Collector app for ArcGIS. For the survey, the shapefile displayed both quailshire and private forestry areas. The survey team could then add details such as areas which were highly vulnerable to runoff, potential areas of interest, so for example, areas that could be potential buffer strips or sumps, areas close to water body. Point and line data were added, such as access points, drainage channels, etc. And based on this survey, the team compiled a prioritization matrix to aid the selection of the site for best practice mitigation measures implementation. From the matrix, the team identified a list of 6 quailshire sites, which would be ideal for implementing mitigation measures, such as the planting of broadleaf native tree species to act as splash guards, creating sumps or swale areas to improve filtration of sediments and chemicals, and planting of willow or birch in areas of water setback. We also looked at areas for woody dams along drainage gullies and at the edge of plantations. All of the data was collated on the Catchment Care Forestry Survey dashboard created by Donegal County Council. Discussions with quailshire have highlighted that due to the longevity of forestry crops, paired with mitigation measures being implemented by quailshire themselves in 1991, it is highly likely that no significant mitigation measures could be implemented by the Catchment Care project. Disturbance of mature crops for mitigation measures is likely to result in a loss of crop yield, which will also not be tolerated by quailshire. Additionally, as crop assemblages are staggered between publicly and privately owned crops, securing a continuous area along a watercourse which would give the greatest result for water quality is unlikely. New strands of crop, that's everything planted after 1991, are being planted with mitigation measures in place that would have been suggested by the catchment care team regardless. Therefore, it may be a matter of allowing historic crops to be felled and new crops to be planted with cautious mitigation measures to effectively address issues resulting from forestry plantation. The catchment care team are hoping to identify a suitable site to use as a demonstration for the installation of stepped limestone drains in drainage gullies on a plantation. The aim of this would be to investigate the buffering capacity of limestone on water runoff from plantations, which could be used as a tool in tackling increased pH levels for receiving waters, an issue which is widely associated with the presence of conifer plantations. The catchment care team want to use the results from the sheep dip survey and the forestry survey to select sites to monitor to actually quantify the chemicals identified as being of interest being exported into the water bodies. The Lochs Agency team compiled a detailed literature review of another number of methodologies for carrying out this work. A number of systems were considered. We concluded that we required a passive sampling system in order to give us a complete time series information rather than point sampling. It was initially decided that the ChemCatcher system was the most suitable method for carrying out the required sampling. However, when we investigated the practicalities of using this method, it became apparent that there was no real lab capability in the UK or Ireland to complete the analysis of the passive samplers for all of the analytes that we wished to consider. The use of passive samplers for detection of pesticides and herbicides is documented throughout Europe and worldwide. But this method of sampling, particularly for pesticides, has not been widely practiced on the island of Ireland. Some studies on the use of passive samplers to detect cypermethrin have been carried out by Dublin City University. However, in various discussions with other scientific agencies on the island, we were unable to discover any other examples. In order to undertake all of what we wanted to investigate, we've had to go with a fairly novel approach. The system we are looking at is a composite suite of samplers approach, which will allow us to passively monitor sites over the period of a year continuously with monthly results. The ChemCatcher system will be paired with two other passive sampling devices, POCIS, which will collect acetamiprid, and Silicon SSP M823, which will collect cypermethrin. This system of using a suite of passive samplers will allow us to collect accurate time-weighted concentrations of cypermethrin, acetamiprid, diazinon, which is an organophosphate, and MCPA. The plan is to undertake a preliminary study in 2021-2022, which will hopefully give us quantifiable data on chemical presence in the water bodies in the Finn. In order to mitigate against the issue of chemical export from land use to waterways in the Finn catchment, the team has been working to raise public awareness in the relevant sectors. The team has been working closely with the Irish Hill Farmers Association and Teagasc to get the message out with regards to safe use and disposal of sheep dip products. In addition to the questionnaires undertaken at the marts, Catchment Care has created and distributed an infographic on best practice. We also hosted a sheep dip demonstration day in September 2020, where the farmers in the Finn catchment came together to learn about the dangers of releasing sheep dip into the watercourse and how to handle disposal responsibly. We used the demonstration day to produce an educational video, which has been widely distributed, and it's up on the Catchment Care channel, YouTube channel, if you want to have a look. It's hoped that we can host this event as a more farmer participation event in the future when restrictions allow. The idea would be to host these events seasonally to coincide with the time of year when the farmers dip their sheep. This was a great day and the feedback on the video has been really well received. So hopefully this is the first step in changing attitudes and behaviours. As discussed, forestry practices and attitudes towards chemicals are now largely self-regulating, and the sector has made huge strides towards more environmentally safe practices. The Catchment Care team has produced a forestry infographic for all the owners of private stands in order to further raise awareness of best practice. It is hoped that this multi-pronged approach to the issue of chemical export from land use to water bodies will give us a clearer picture of the magnitude of this issue, raise public awareness, change behaviours, and ultimately lead to the reduction in the amount of chemicals entering the water in the Finn catchment.